Hello! Today I will be giving you all a very basic overview of epigenetic modification. To begin, we will look at our X chromosome, which consists of two individual chromatids who are sister chromatids, so they are identical, meaning that this half is going to have the same genetics as this half. That entire chromosome is 1400 nanometers in diameter, with the individual 700 nanometers in diameter chromatids. This is going to be our chromosome that is visible during metaphase. So our chromosome here and our individual chromatids here. Moving in just a little bit closer, we will actually see that this chromosome is made up of a bunch of chromatin fiber. This is condensed beads on a string. When we get more zoomed in, we'll actually see that. But this tangled up fiber is going to be 300 nanometers in diameter, and that is what makes up our chromosome. So moving into actually looking at that chromatin fiber, when we pull those individual strands out, we have untangled chromatin fiber. So these are going to be 30 nanometers in diameter, making up this larger, tangled, I like to call it, chromatin fiber. Now, if we actually look closer at that individual strand, what we'll find are these nucleosomes. These are going to be our beads on a string, and these are all individual histone proteins that are wrapped around in DNA helixes and then in a grouping together. If we look even closer at that, what we will see are these individual histone proteins wrapped in that DNA helix. These are wrapped in a DNA helix twice over, or in 147 base pairs, making up our nucleosomes. Whenever we have our nucleosomes all together like this, we can have open chromatin and closed chromatin. Our closed chromatin is going to be whenever this is all tangled up like this and very compact. We can't actually recruit any transcription machinery here to go through and transcribe the genes that are on this DNA helix. There is just simply no room for them to move around. But if we have open chromatin, like here, we actually can recruit that transcription machinery to move along this DNA helix, transcribing the genes that are on it. These individual histone proteins are made up of 8 core proteins. Not shown here in the diagram, but these histone proteins have histone tails. And these histone tails are open for modification. We can have methylation, commonly trimethylation. We can also have acetylation or ubiquination. Additionally, we can have phosphorylation. And as shown, we can have many different of these tags on many different histone tails. So looking here, we have histone modification, which results from both the environment and genetics, which alters DNA expression. Whenever that transcription machinery is actually moving across the DNA helix, it will transcribe the individual changes made to that histone tail on one of the 8 core proteins. Those histone proteins are lined with the DNA helix, made up of the sugar phosphate backbone, and then also our individual nucleotides. The DNA helix is 2 nanometers in diameter and wraps twice around the histone proteins, or 147 base pairs. But how do we open and close chromatin? Whenever we have closed chromatin like this, what we can do is acetylate it. And when these histone proteins get acetylated, what they do is they actually open up. And so whenever we have this acetylation, we actually have these nucleosomes that are able to recruit transcription machinery that will move along and transcribe those genes. We can also methylate these histone proteins. And once again, modifying the tails on those 8 core proteins. So, whenever we methylate this chromatin, what happens is it actually condenses back. And once again, we cannot actually recruit any of that transcription machinery as we are all tightly bound up. In between each of these nucleosomes here, or these histone proteins with the DNA helix wrapped around them, are H1 proteins. These are not shown here, but they are in between each of these. Whenever our DNA is methylated and condensed, we will also be methylating at CpG islands. So these are just areas that are rich in those GC bonds. So overall, this is our final full diagram. Methylated closed chromatin. Acetylated chromatin, open. Histone tail modification. And then finally our DNA helix. Today, the question we are going to explore is, how do my lifestyle choices actually affect how my histone tails are modified?